Okay, so with this question, we've been asked to determine the equation of the perpendicular bisector of the line formed between A and B. Now, before we actually try and do any of the maths on this, let's actually try and work out what is a perpendicular bisector. Well, let's look at the name. First of all, it's got to bisect the 2 points, so it's got to be halfway between the two. And it's got to be perpendicular, so it's got to be at right angles. So when we have a look at this, what we've got here, I've graphed the 2 points here to just make it clearer. You don't necessarily need to do that, but if we just have a look at what we're trying to get here, and it might help us come up with the answer later on, we've got the line that's getting formed between those 2 points, and we want to bisect that line, so halfway between the two, down here somewhere, at right angles, and we want to work out the equation of that line. So before we actually set out to do any of the maths on it, we can work out that this line is going to have a positive gradient because it's going up as we go from left to right. We can work out, roughly what the y-intercept is, so that's going to help us a little bit there. So the first thing is to actually work out, to make this bisect, we need to have the midpoint of those 2 points. So we can start off by saying, okay, well, the midpoint of A and B, well, this is the formula that we use, which is a pretty simple formula. All you're doing is you're saying, well, I'm going to work out the average of the x coordinates. Okay, so average of the x coordinates, average of the x there, and average of the y coordinates. And we've written it this way because it is actually a coordinate. So I'm going to have my brackets, have the comma in between. We can go ahead and label x1, y1, x2, y2, and we're going to say, well, x1 is -3 plus x2, which is 5 over 2, and y1 is 8 plus y2, which is -12 all over 2. And so let's have a look at what we get given here. -3 plus 5 is 2, so it's 2 over 2, and this becomes a negative here, so that's 8 minus 12, which is -4. So we've got -4 over 2, and when we simplify that, we end up getting a coordinate of 1, -2. So if we have a look, I've kind of, almost got it. It's a little bit more over here is our coordinate 1, -2. So when I've gone into to sort of try and bisect that line, I'm just a little bit off there, and I haven't drawn my line very well, but that is the coordinate 1, -2. So I know that I'm roughly on the right track here. So after that, we want to work out, well, it's got to be the perpendicular bisector. So for a line to be perpendicular to this line here, the gradient needs to be the negative reciprocal of the gradient of this line. So the next thing you want to work out, well, is what is the gradient of this line? Okay, so we've worked out the midpoint. Let's work out the gradient. So our gradient, remember m, lowercase m, is our gradient, and our gradient formula is y2 minus y1 over x2 minus x1. We've already got it labelled as x2, x1, y1, x2, y2, so let's go ahead and sub those in. So we've got y2 is -12, -12 minus y1, which is 8, all over x2, which is 5, minus x1, which is -3. And so let's go ahead and simplify that. -12 minus 8 is -20. Over this becomes a positive here when we've got 2 together. That must be together. This is not together. This is minus $12 minus another $8. This is where we've got 2 negatives together. So that gives positive 8. And let's simplify that. So, you can divide both of those by 4. So we've got negative, this getting divided by 4 is 5, and this divided by 4 is 2. So -5 over 2 is the gradient of our line between A and B. So this gradient of, I might just say it's a gradient of AB. So the gradient of the line that is perpendicular to that then must be the negative reciprocal of that. So I'm going to write a little note here that the gradient of the line perpendicular to AB is the negative reciprocal which simply means we're going to flip the fraction and change the sign. So the m, which is perpendicular, we'll just put a little symbol there for that, is 2 over 5. So now we've got little bits of information that we're going to use then to work out the equation of that line. Okay, so we've got the gradient and we know at least a point on the gradient, which is the midpoint here. So we're now going to use the equation of line formula. So y minus y1 equals mx minus x1 to work out the equation of that line. So let's go and stick all that in. We're going to leave y as y minus y1. Now y1 in this case, we've got x1 and y1. y1 is going to be negative 2. So negative 2 goes in. Our gradient is 2 over 5. We're going to leave that as x minus x1, which is 1. Now we've got two negatives together that makes a positive, so we're going to have y plus 2 is equal to 2 over 5x when we expand here. And then expand this again, and that's going to give negative 2 over 5. And then we just need to go through and solve this equation to make y the subject, or rearrange to make y the subject, I should say. So we're going to subtract 2 from both sides. Now I'm going to put, it's a constant term that I'm adding over here, or subtracting over here, so it's going to go next to the constant term. I'm not going to put it here next to the x term. Okay, so we're going to have y equals 2 over 5x, and negative 2 minus another 2/5 is negative 2 2/5. So that's our final equation of the line. I've left it in gradient intercept form. It hasn't asked us to leave it in standard form or general form or anything like that. So that's how we do it. If I just check whether that's a reasonable answer, let's just have a bit of a look. I was a little bit off earlier. So if I sort of work out roughly perpendicular, it looks like, yeah, we're going cross 5, every 2 up we go, and it looks like, yeah, it might pass through negative 2 2/5. I'm just going to quickly show on Desmos. That's where I've got those 2 points, and let's just enter in the equation to see whether it looks right. Desmos, y equals 2 over 5x. We're going to go minus 2 and 2/5. Now 2 2/5 is 2.4. So yeah, we can see pretty well from that. I might just put in the equation of the line that we had before, which was that, and then we had to, got to go back and check what it was. Where are we? Over here. The equation of that line. Oh, I didn't work out what the equation was. Could work out what the equation was, but you can see that's going to be very, very close to that. I must have to add something 2/5 there to get it across. Not quite, I don't think it's going to go quite through there. But yeah, you can see that it is perpendicular. You can see that, yeah, it is crossing there. So our perpendicular bisector looks pretty bang on for that.